This diagram shows a custom web form on the left, sending data directly into a spreadsheet database on the right. You hit Submit, and the data instantly appears in the grid. We are going to build this exact pipeline using nothing but standard vanilla JavaScript and the native Fetch API. No heavy third-party form plugins, and no legacy libraries like jQuery. To build this, you only need two things: a basic text editor to write your code, and a pre-configured Google Apps Script web app URL to receive the data. By coding this connection yourself, you own the entire process. You control exactly how the interface looks and exactly how the data is routed, completely free from the constraints and monthly fees of third-party form providers. Step 1 is setting up the HTML skeleton. We start with a standard form wrapper, and inside it we place our basic text inputs for things like names and email addresses. For yes or no questions, we use an input tag set to type checkbox. This allows us to capture strict true or false Boolean data. If you need users to pick from a specific list, you build a dropdown using a select tag filled with nested option tags. You can also structure visual lists on the page using standard UL and LI elements. This diagram shows the most critical part of the markup. Every input element must have a unique ID attribute, like ID equals newsletter-tick. These unique IDs act as exact coordinates. When we write our script, we'll use these exact coordinates to locate and extract the data. A clean semantic HTML structure mapped with strict IDs gives you a stable, predictable foundation. Without it, the data capture system will fail to locate the user's input later on. Now we move to the JavaScript file. Before we try to grab any of those IDs, we have to instruct the script to wait until the Document Object Model, or DOM, has fully loaded. The DOM is the browser's internal map of the HTML page. Once the page is ready, we use getElementIID to target the main form wrapper. Then we attach an ad listener to it, telling the script to watch specifically for the moment the user clicks Submit. Here is where most initial setups fail. By default, when a browser submits a form, it triggers a hard page refresh. That refresh instantly destroys the JavaScript environment before your code can even run. To fix this, we pass the event object, usually labeled E, into our function and call e.preventDefault. This command explicitly blocks the browser's default refresh behavior, keeping the script alive and running. By hijacking that default refresh, you take control of the browser's routing. Your static HTML page is now functioning as an interactive, asynchronous web application. With the form successfully intercepted, step 3 is organizing the input. We start by initializing a completely blank JavaScript object. This will act as our warehouse to temporarily store the user's data. We pull the text string values from our standard inputs, like the user's name, by targeting their specific IDs and appending the .value property. Tick boxes require a slightly different approach. Because they don't hold text, we extract their true or false state using the .checked property instead. This diagram shows that warehouse object output to the console. The extracted form data is cleanly organized into a standard JavaScript object structure. But a server cannot read this. We must convert it into stringified JSON format using the json.stringify command, standardizing the data. Standardizing all those disparate text fields and checkboxes into a single strict JSON string creates a universal payload. That string is the required language for bridging the gap between your front-end interface and your back-end database. Now, step 4 is sending the data. We set up the Fetch API configuration object and define our HTTP method as post, instructing the server that we are sending new information to be saved. Next, we take that newly stringified JSON data and attach it directly to the body property of our fetch request. Here is the second major point of failure. If you send this request right now, the destination server will reject the payload because it lacks the proper format context. This diagram illustrates the solution. We must define explicit headers, setting content type strictly to application.json, telling the server how to parse the data. With configuration locked in, we execute the transfer by passing our endpoint URL and configuration object into the fetch command. Because this request travels across the network, we chain a .then method onto the fetch. This forces the script to wait for the server's reply, allowing us to parse the success message and confirm the data arrived. Finally, we append a .catch block at the end of the chain. If the user's internet drops or the server is down, this block intercepts the error so the application can degrade gracefully instead of crashing. By properly configuring the native Fetch API, you achieve a streamlined, highly performant data pipeline. It removes the technical debt and bloat of legacy AJAX wrappers. AJAX means asynchronous JavaScript and XML, an older approach to network requests. This modern Fetch approach keeps your codebase lean and fast. The pipeline is built. Now we validate it. We populate the custom HTML form on our live page with sample data and click Submit. This diagram shows our browser's Developer Tools network panel. We can see the successful post request, and if we inspect it, our JSON payload is perfectly formatted and visible in the outgoing headers. And when we open our target Google Sheet, the identical data has populated instantly into the correct columns, exactly as we mapped it. You now have a secure, lightweight pipeline that connects user input directly to a database. It requires no heavy dependencies, relies purely on native browser standards, and is ready to be embedded into any digital environment you design.